Welcome back to another Explainer. If you've stepped outside during the past few summers, well, you've probably felt it firsthand. Temperatures are absolutely shattering historical records. I mean, we're seeing entire continents baking under unprecedented heat. It's completely rewriting the meteorological record books. Extreme heat isn't just some rare, once-in-a-lifetime anomaly anymore. It's rapidly becoming our new, grueling reality. And it's impacting everything: our physical health, our local economies, and the very ecosystems we rely on. So today we are going to unpack exactly why this is happening.
Okay, let's take a quick look at our roadmap for today's explainer. We're breaking this down into 5 steps. First, defining the heat wave. Second, mechanics of extreme heat. Third, Earth's rising thermostat. Fourth, the deadly impacts. And finally, solutions for a warmer world. Let's get to it. So what exactly is making these extreme heat waves the new normal? That's the core mystery we need to solve here. Is this all just natural climate variability, like a strong El Niño cycle temporarily bumping up the numbers? Or has our fundamental planetary baseline irreversibly shifted beneath our feet? Section 1. Defining the heat wave. First things first, we need to draw a hard line between a standard hot summer day and the compounding threat of a true heat wave. Because actually, not every hot day qualifies. Ordinary hot weather might last a day or two, and yeah, it's uncomfortable, but things usually reset. Heat waves? They are an entirely different beast. They combine exceptional temperatures, a long duration, usually at least 2 to 5 days, widespread geographic coverage, and crucially, limited nighttime cooling. That last point is absolutely essential. Without that nighttime dip in temperature, your body never gets a chance to recover from the daytime heat stress. Exhaustion just builds and builds to dangerous levels.
And here's where it gets interesting. There is no single, universal temperature threshold that defines a heat wave. It's totally relative. For instance, 35 degrees Celsius, that's about 95 Fahrenheit, might trigger a catastrophic emergency in parts of Northern Europe. But that exact same temperature, that's just a totally normal, everyday summer afternoon in a desert region. It all boils down to what the local populations, ecosystems, and city infrastructure are historically adapted to. A city's building materials and air conditioning access really dictated survival threshold. That's exactly why a relatively mild heat wave in London can actually be far deadlier than a numerically hotter one in Dubai.
Section 2. Mechanics of extreme heat.
Okay, so how do these things actually form? One of the major drivers is a phenomenon you've probably heard of: the heat dome. Picture a giant, invisible atmospheric pressure cooker. It kicks off when a persistent high-pressure system just parks itself over a region, trapping all the warm air underneath it. Inside this dome, the air is forced to sink, and as it sinks, it physically compresses and warms up even more. Plus, this high pressure basically acts as a shield, suppressing cloud formation. So the sun just continuously beats down, directly heating the ground. Day after day, the heat accumulates, with absolutely no relief. It's essentially a stagnant lid that mercilessly cooks everything caught underneath it.
Now, this dome interacts directly with the jet stream, that incredibly fast-moving river of air way up in our atmosphere. Usually, the jet stream pushes weather systems along at a nice, healthy pace, but when it gets unusually wavy, those weather systems slow way down. Meteorologists call these blocking events. It is basically a massive traffic jam in the sky. Those high-pressure systems get completely stuck in place, blocking any cooler air or refreshing storms from moving in, and trapping that intense heat for weeks on end. Down on the ground, things get even worse thanks to a devastating natural feedback loop. Think of wet soil like the Earth's sweat. It acts as a natural evaporative cooler. Normally, a lot of solar energy goes into evaporating that moisture, which keeps the surrounding air relatively cool. But during a drought, you have dry soil. The Earth's sweat is completely gone. That means almost all of the sun's energy has nothing left to do but bake the air directly, driving up temperatures. And that hotter air aggressively evaporates any tiny bit of remaining moisture, leaving you with even drier soil the next day. It's a vicious, vicious cycle.
And if you live in a city, you're facing a whole other localized magnification of this heat. We call it the urban heat island effect. Cities are packed with dense, heat-retaining materials. Asphalt absorbs heat so intensely it can literally cause severe skin burns in seconds. Meanwhile, concrete actively stores that thermal energy deep inside. Add in tall buildings blocking the natural wind flow, a severe lack of cooling vegetation, and the waste heat pumping out from millions of air conditioners and car engines. All of this combined keeps urban centers up to several degrees hotter than the surrounding rural areas, and you really feel it at night when all that concrete finally starts releasing its stored heat.
Section 3. Earth's rising thermostat.
Let's zoom out for a second and look at the Goldilocks effect that keeps our planet habitable. Without naturally occurring greenhouse gases, Earth's average surface temperature would be a freezing -18 degrees Celsius. Life as we know it simply wouldn't exist. But with them, we sit at a comfortable, life-sustaining +15 degrees Celsius. This natural greenhouse effect acts like an invisible blanket around the globe, absorbing outgoing heat and re-radiating it to warm the lower atmosphere. It's an incredibly delicate balance, and it's kept our climate stable for thousands of years.
But over the past century, well, that delicate balance has been completely overwhelmed. Since the Industrial Revolution, atmospheric carbon dioxide has spiked from about 280 parts per million to well over 420 parts per million today. And it's not just the amount that's alarming here, it's the sheer speed of the change. In geological terms, this massive, unprecedented spike has happened in the absolute blink of an eye. It's fundamentally and aggressively strengthening the planet's natural warming process way beyond its historical capacity.
So where is all this extra gas coming from? Basically, our modern way of life is pulling a massive, invisible lever on the global thermostat. Burning fossil fuels like coal, oil, and gas to power our lives is by far the largest contributor, but it's totally interconnected with our need for food and space. Deforestation destroys the very trees we rely on to absorb carbon. Agriculture adds massive amounts of highly potent methane to the mix, and the industrial processes we use to build our infrastructure, they flood the atmosphere with even more emissions. It's a combined systemic pressure from all sides.
Now, for years, people would ask, was this specific terrible heat wave caused by climate change? Well, researchers now have a fascinating tool to answer that. It's called attribution science, and it's basically forensic detective work for weather. Scientists run advanced climate simulations of our current world, the one filled with human emissions, and compare them against simulated versions of a world without any human influence. This gives them the exact fingerprint of climate change. It allows them to definitively state if human-caused global warming made a specific, localized heat wave significantly hotter, more likely, or longer lasting. To really grasp why records are falling so frequently, imagine a bell-shaped curve that represents all daily temperatures throughout history. The bulky middle part, that's your average weather. The thin, tapering edges represent extreme cold and extreme heat. Now, as the global average temperature rises by just a tiny fraction, that entire bell curve shifts slightly over to the warmer side. That seemingly small shift completely transforms the extremes. What used to be an impossible, off-the-charts heat event suddenly falls right into the realm of regular possibility. That is the exact mathematical reason why rare, record-breaking temperatures are increasingly becoming an everyday reality.
Section 4. The deadly impacts.
Heat is actually one of the deadliest weather hazards on Earth. It's often called a silent killer because it doesn't have the dramatic visual destruction of a tornado or hurricane, but it puts immense, prolonged physical stress on the human body. We're talking everything from severe heat exhaustion to life-threatening heat stroke, which happens when internal body temperatures exceed 40 degrees Celsius. It forces your cardiovascular system into overdrive and can cause serious kidney damage. But here's something really surprising. It also drives severe mental health impacts. Extreme heat is closely linked to increased anxiety, aggressive behavior, cognitive decline, and chronic sleep disruption.
The natural world suffers just as intensely, and those cascading consequences eventually circle back to all of us. Extreme heat rapidly accelerates drought, basically turning healthy forests into tinderboxes primed for massive wildfires. It shrinks river flows and accelerates glacier melt. Down beneath the ocean, marine heat waves trigger devastating coral bleaching, collapsing entire underwater ecosystems. And remember, when rivers dry up and forests burn, it's not just an isolated tragedy happening somewhere far away. It directly threatens the drinking water, the air quality, and the food supply for millions of people downstream.
Beyond the physical and environmental toll, the economic costs are genuinely staggering. When it gets physically too hot to work safely outdoors, global labor productivity just plummets, costing billions of dollars. Extreme heat severely damages plant tissues and disrupts pollination, threatening the global food supply chain with massive crop losses. We're even seeing wild infrastructure failures. I mean, we're literally seeing airport tarmacs melting and sticking to airplane tires. Train tracks warping under the intense sun until they look like a bowl of spaghetti, completely halting transportation networks. It's wild.
Section 5. Solutions for a warmer world. To protect ourselves, we have a robust, three-tiered defense plan. First up is mitigation. This is about tackling the root cause by expanding renewables, electrifying our transport, and fiercely protecting our forests. Second is adaptation, which means physically altering our environment to cope. For example, simply installing green roofs with vegetation can dramatically lower a building's internal temperature, which saves both lives and energy. And third, individual actions.
These are the immediate, practical steps you must take during a heat wave. Things like staying hydrated, seeking out cooling centers, and crucially, checking on your vulnerable or elderly neighbors.
While extreme heat is indeed the new baseline we have to live with, the severity of future changes depends entirely on us. The new normal absolutely does not have to become a doomsday normal. The science clearly shows that our future is not yet predetermined. If we implement rapid emissions reductions alongside aggressive local adaptation measures, we can substantially reduce those future risks. We still hold the agency and the power to shape a significantly safer and more resilient trajectory for the planet.
We know for a fact that every additional fraction of a degree of global warming raises the likelihood of severe, life-threatening heat extremes. The science is completely clear on the mechanics and the impacts. So the question now is, with the stakes getting higher every year, how will you and how will your community adapt to thrive in the summers of tomorrow? Thank you so much for joining us for this explainer. Stay cool, stay informed, and we'll see you next time.